Hello everyone, my name is Isabel. I'm with VALUENEX, and today I'll be presenting on how we can harness NLP to map the evolving landscape of quantum technologies. So, a little bit about VALUENEX. So firstly, VALUENEX was founded in 2006 in Tokyo, and we have over 15 years of dealing with over 300 major corporate clients over 20 different industries. We have worked with over 50% of the Japanese companies in the Global Fortune 500, as well as over 3/4 of Japanese companies in the Thomson Global Innovator 100. And here are some of our clients in the bottom right. So before we get into showing how the VALUENEX radar works, I'll explain some of the features and definitions. So starting in the far right, we have our major areas, which pinpoint highly competitive areas. We can see over here the VALUENEX radar is a heat map, which shows the density of different areas within a specific corpus of documents. Going counterclockwise, we have the sparse areas, which highlight areas of opportunity within a space. These are some of our most valuable insights that we can provide through the VALUENEX radar and showcases areas of research or patents that have the most potential to grow within a space. Nextly, we have our trend lines, which map portfolio evolution and future direction. So one of the trend lines you can see on the right maps the evolution of a particular company. We can also map the particular evolution of different industries, which what we'll be showing you today with the overall quantum industry. Next, we have our centers of gravity and distribution area, which show breadth of core R&D. So with the center of gravity and distribution areas, we can see the things that companies like Google, IBM, and so on and so forth are doing. And lastly, we have our growing areas, which are areas that indicate faster growth than other regions. So today, we'll be looking at the quantum technology landscape across two different areas. Firstly, we'll be doing an analysis of patents filed within the last 20 years. And secondly, we'll be looking at quantum technology research papers. So the key questions that I want to have in mind when doing this presentation is firstly, what are the key trends and opportunities in quantum technologies overall? Secondly, how are different quantum technology companies differentiating their focus? And third, we have how do trends across quantum patents and research papers compare? So firstly, we have our analysis into quantum technologies. For our search query, we looked at all the different tracks that were going to be covered here at Q2B, such as quantum computing, quantum sensing, quantum communications, and sourced all the patents related to that, or patent applications related to that from the US Patent Office. And our time range for looking at these are patents published between 2004 and 2024. And from that, we got over 3,000 patent applications with over 1,000 clusters. So here is the quantum technology landscape across quantum computing, quantum sensing, and quantum communications. It looks like a lot, but on our next slide, we'll be able to simplify it down for you. All the areas in the left, labeled in blue, have to do more with quantum computing-related patents. The areas in purple at the top have to do more with quantum sensing, and in the bottom right we have the pink patents that have to do more with quantum communications. An important clarification that I want to do here is that the area labels do not necessarily mean that the topics are exclusively in that area, but more that there is the most density of them in that area. So for example, quantum dots is not solely a quantum sensing technology whatsoever, but that the high area of density in quantum sensing research or patents have to do mainly with quantum dots. So when we simplify the different areas, we can see that this area on the left has to do with quantum computing, quantum sensing at the top, and then quantum communications. And so, really zooming out and going away from all of the different labeled areas, we can then start to analyze larger trends within quantum technologies as a whole. We can see our trend line here, which shows how the center of all these patents filed has evolved over time from 2014 to 2024. And we can see that there is a very clear line going from more in the direction of quantum sensing in 2014 down to the area of quantum computing and quantum communications, the bottom of the radar here in 2024. And so these next couple of slides will be, investigating the reasons why this trend line might have gone this way. So looking in the 2024 landscape, we can see we filtered all the patents that were filed in 2024. We can see a hotspot in quantum error correction, variational quantum algorithms, quantum key distribution systems, as well as quantum services. Quantum error correction has been very much a hot topic here at Q2B, so probably don't need to explain as much as that. But we can also see that there's a growing area of quantum services where we can see companies filing patents on bringing quantum computing as a service or quantum computing to different industries such as chemistry and pharmaceutical. We can see the white spaces in between our different areas of quantum computing, quantum communications, and quantum sensing. So a little bit more about our white spaces. We've presented at the last couple of Q2Bs here at Silicon Valley, as well as Q2B Tokyo. And in our last couple Q2B presentations, we focused mainly on quantum computing and mentioned the white spaces in quantum computing. And in our previous presentations, we analyzed that there was a white space in between software and hardware in quantum computing. And now here at Q2B, we've heard a lot of people talk about the need for software for hardware control. So we wanted to really zoom out and see the larger picture, like where else can we see white spaces? Where can the quantum technology is, and where is industry going? We can see a large white space in between quantum computing and quantum communications, as well as a smaller white space between quantum communications, as well as quantum sensing. Our interpretation of this is, the high potential for patents and technology bridging quantum computing and quantum communications. There's been a lot of talk about, quantum networking, building larger quantum computers from smaller quantum computers through advances in quantum networking. So we anticipate through this white space, as well as the other technologies we see in that space, that trend to continue. We can also look at the different companies within a sparse area. Over here, we see that the top competitor within this sparse area is IBM. So, they have kind of the monopoly on what's going on in the white space. But we can also see companies like Toshiba, AHP Tech, and PsiQuantum Corp not super far behind. And we can also see the trends within this white area. We can see that it's an area of low density collecting areas of high density within the space, like high density areas like error correction or quantum key distribution. Up until 5 years ago, not a lot of patents were filed within this space, but then we can see within the last 5 years, the patents filed within this area are really starting to take off. So we anticipate that this sparse area holds, again, a lot of potential. We can also look at what particular companies are doing within a space by filtering. We can see IBM. A lot of their focus has to do more with variational quantum algorithms and AI and machine learning models. Versus looking at Google, we can see that they have a really high focus in quantum error correction. Something interesting is that we actually created this radar a couple weeks ago before Google's big announcement regarding, their advances in error correction. So it was really interesting to see the announcement a couple of days ago and know that we had this in our slides, and that, Google's investment and heavily into quantum error correction has now made it out into the media, the public news. We can also see IonQ has a lot of investment in ion traps, ion chains, and neutral atoms, versus a company like Toshiba mainly has their patents filed in the area of quantum key distribution systems and encryption processes. Next, we wanted to look at research paper analysis because, patents filed, there's a lot of lag between what's actually happening in research now versus patents filed, 18 to 24 months later. We looked at a very similar search query to the patents. We looked at quantum computing, communications, and sensing again, and pulled our data from Scopus. Instead, we looked at the last 10 years and pulled almost 10,000 research papers to do a radar with almost 3,000 clusters. So here is the quantum research landscape. Again, the areas in blue, such as quantum error correction, quantum circuit optimization, quantum annealing, are the most high-focused areas within quantum computing research. Within quantum communications research, we have a lot of focus in post-quantum cryptography, quantum key distribution, optical vortex beams, and photon detectors. Within quantum sensing, we have spin qubits, Josephson junctions, and then lots of research in defect utilization, such as nitron vacancy centers and boron nitride. Again, we want to zoom out and look at the larger picture, simplify it, and see the different trends within the specific industries or specific areas within quantum research. Similar to the patents, we see a trend line that is going away from quantum sensing and more into the heat of quantum computing, largely driven by research in the error correction, and so that's in that area to the top. When we want to really see how this trend could have taken place, we can see that filtering in 2019, there's a lot of distribution within the patents. There's, again, a lot of focus. There was a lot of focus in defect utilization and post-quantum cryptography. Versus looking at 2023, we can see that there was a massive increase in research in quantum error correction, quantum annealing, and in the areas of quantum machine learning, as well as spin qubits and defect utilization for quantum sensing. Most interestingly, when we look at research conducted in 2024, we see this extremely red and dense spot in research in quantum error correction. This doesn't mean that research in all the other areas has gone down. In fact, research in all of the other areas, the research papers published have all gone up. But just the rate of increase for quantum error correction has been so great in 2024 that it shows up as a big, bright red spot onto our radar. We also want to look at the white spaces within quantum research. We can see quantum communications is here. There's a one connected white space versus the two connected white space within quantum patents. And over here we saw research in things like analogs, interconnects, as well as other topics related to the intersections of technologies related to the three. We also wanted to compare the trends between research and research papers and patents. Firstly, looking at the white space. Again, there's a, they're very similar in that their white spaces identified are in between the three different industries, showing that, there's a large potential for the three industries to, converge, or technologies to emerge in between the three different industries. We can also look at the comparison in 2024 between patents and research papers. Again, as everyone knows, there is sometimes, a lag between research conducted and then the filing of patents. So we thought it would be really interesting to see what's happening in 2024, which maybe we'll look at in, the patent radar months to years from now. We can see that patents filed in 2024, a lot of activity in quantum computing and quantum communications, and not as much in quantum sensing. We can see that the areas of highest density are quantum error correction, as well as quantum key distribution in quantum communications. But when we compare that to the singularity of quantum error correction in research papers, we can see and predict that maybe there will be a spike in error correction patents almost months from now. So key takeaways from the 3 questions that we talked about earlier were, firstly, what are the key trends and opportunities in quantum technologies overall? So again, the 10-year trend line is driven by a recent increase in patent filings and research in error correction, particularly in 2024. Additionally, we've seen that significant white space exists between quantum computing, quantum communications, and quantum sensing. Secondly, we wanted to look at how different quantum technology companies are differentiating their focus. IBM has a broad approach, emphasizes quantum algorithms development. On the other hand, we have Google prioritizing error correction, IonQ specializing in ion trap technology, and Toshiba focusing on quantum key distribution. Lastly, we wanted to look at how the trends across patents and research papers compare. The white space exists between 3 domains of quantum computing, communications and sensing. However, in 2024, research papers showed a singularly strong emphasis on error correction. Patents also showed this focus in error correction, but it is less distinctly represented on the heat map. So, looking ahead, this was a very, high-level map across, the 3 different industries: quantum sensing, quantum communications, quantum computing. In the past, we've only focused on quantum computing, and we can also zoom in even further onto different industries. So if you are interested in exploring R&D landscapes for your company, seeing where you land on any of these patent or research landscapes, or any text document, we would love to work with you to unlock insights and drive innovation. And so here is our email. You can reach out to us at customer@valuenex.com, or we have our office in Palo Alto. The address is over here. And that is it. Thank you so much.